day everyone, I am Miss Marielle Andres for another mahuSCIE video. For today's lesson, we will be talking about the behavior of gases, particularly about the Boyle's Law. So, come on, join me and together, let's be mahuSCIE. Like solids and liquids, gases are also made up of molecules. The properties of gases can be attributed to the random and scattered arrangements of its molecules. This is because gases have very weak intermolecular force of attraction. For today, let us learn more about the properties of gases through the different gas laws. When we talk about gas laws, we need to consider four variables, namely pressure, temperature, volume, and amount, which is expressed in moles. Pressure is described as the amount of force exerted per unit area. To measure pressure, we use the units atmosphere, millimeter mercury, torr, pascals, or kilopascals. Since atmosphere is the standard unit for gas pressure, you will be seeing values expressed in atmosphere most of the time for our entire lesson. When the generalized variable of pressure is discussed, the symbol P is used. Next variable is temperature. We already know that temperature is the degree of hotness and coldness. However, we will be expanding its definition as the measure of the average kinetic energy of the particles in an object. This means that the faster the particles move, the higher the temperature will be. We measure temperature using the units Fahrenheit, Celsius, and Kelvin. When the generalized variable of temperature is discussed, the symbol T is used. The third variable is volume. Volume is the three-dimensional space occupied by the particles. For volume, we often use the units liter, milliliter, cubic meter, and cubic centimeters. When the generalized variable of volume is discussed, the symbol V is used. And lastly, we have the amount, which is expressed or measured in moles. The letter N is used as the symbol for the amount of gas. Now, all these four variables affect one another, and in order for us to see how one variable affects another variable, we have to hold the other two variables constant. As I have mentioned earlier, the relationship of these four variables can be shown through the different gas laws. So, let's have the first gas law, which is the Boyle's Law. Boyle's Law relates pressure and volume at a constant temperature and amount of gas. And according to Boyle's Law, pressure is inversely proportional to volume. So what do we mean by inversely proportional? This means that as the volume increases, the pressure decreases. And if the volume decreases, the pressure increases. To better understand Boyle's Law, let's have this situation. Let's depict a gas shown as the blue molecules inside the cylinder that has a movable piston and a pressure gauge. Let's have this as the initial observation. Suddenly, a change happens. The piston is pushed down, thus making the space available inside the cylinder to become smaller, which compresses the gas. The same amount of gas molecules have now less space to move around, thus leading them to hit the walls of the cylinder with increased frequency. With this, we can say that as the volume decreased, what happened to the pressure? Correct! We can observe that the pressure gauge indicates a doubled value as the volume is reduced. We can now consider this change as the final observation. This observation that we have from the initial and then to the final can be expressed using the following formula. For the initial observation, we can say that the initial pressure is inversely proportional to the initial volume. Or, the product of the initial pressure and the initial volume is equal to the K constant, which is the temperature and the amount of gas. For the final observation, on the other hand, we can also say that final pressure is inversely proportional to the final volume, or the product of the final pressure and the final volume is equal to the K constant, which is again the temperature and the amount of gas. Since the product of the initial pressure and volume is equal to K constant, and the product of the final pressure and volume is also equal to K constant, then we can express Boyle's law in the equation P sub 1 times V sub 1 is equal to P sub 2 times V sub 2, where P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. Now, let's try to solve problems involving the Boyle's law. A gas occupying a 4-liter flask at 760 torr can expand to a volume of 8 liters at a constant temperature. Calculate the final pressure. In solving problems, of course, the first thing that we need to do is to identify the given or the known values. In this example, we have the P1 or the initial pressure as 760 torr. We also have the V1 or the initial volume as 4 liters. And we also have the V2 or the final volume as the 8 liters. After identifying the known values, we now identify the required or the unknown value. In this problem, what are we looking for? Yes, we are looking for the P2 or the final pressure. Now that we are done identifying the known and the unknown, let's have the formula to be used. We can use the general formula for Boyle's law or the derived formula. Now, let's have a quick review in deriving a formula. In deriving a formula for Boyle's law, of course, the first thing that we need to do is to simply write the general formula for Boyle's law, which is P sub 1 times V sub 1 is equal to P sub 2 times V sub 2. After writing the general formula, let us encircle the required or the unknown in the problem. And in our example, our unknown or the required is the P2. So, we encircle the P2 or the P sub 2. Now, after encircling the unknown, which is in this problem the P2, let us place on the denominator whatever variable is with the unknown. In this case, what variable is with our unknown? Correct, we have V2. So therefore, V2 will be placed as our denominator for both sides of the equation. Now, placing V2 as our denominator for both sides of the equation will lead to V2 being cancelled on this side of the equation. Thus, we have the derived formula as P sub 2 is equal to P sub 1 multiplied by V sub 1 divided by our V sub 2. So again, in deriving a formula, always remember, just write the general formula first, encircle the unknown, then use the variable beside the unknown as the denominator, then proceed to cancellation. Then there you have it. You have the derived formula. Easy, right? So, everything is set. We have the known, we have the unknown, we have the derived formula. Now, we are ready for the solution. And of course, the first step for the solution is the substitution process. So we substitute the values to the derived formula. We simply substitute the value for V1, the value for our V2, and of course, the value of our P1. After substituting, we simplify the equation.
First, we cancel out the unit liters. Then, we multiply 760 torr by 4. now having just torr as our unit. This gives us 3040 torr divided by 8.
Our final pressure is therefore 380 torr. If we try to look now at the values, V1 or the initial volume is 4 liters. V2 or the final volume is 8 liters. The volume increased. If we take a look at P1 or the initial pressure, we have 760 torr. Our P2 became 380 torr. Therefore, we can observe that the pressure decreased. So, we can say that as the volume increased, the pressure decreased. Now, it's your turn to answer a problem. Get a piece of paper and a pen and answer this problem. Let's start!
A gas in a balloon has a volume of 1.65 liters at 99.24 kilopascals. The balloon is released into the atmosphere, making it expand to 2.2 liters without a change in the temperature. What is the new pressure of the balloon? You may pause this video as you answer the problem. Be sure to send your answers to the mahuSCIE page afterwards.
So there you have it. Don't forget, Boyle's law states that pressure and volume are inversely proportional at constant temperature and amount of gas. I hope that you have learned something for today's video, mahuSCIEs. Next time, we will be discussing about the other gas laws. Good day and stay mahuSCIE!